Lots of yeses coming through. Perfect. Well, there are lots of yeses coming through, so I think we are all set. Here we are in week 8 of kitchen chemistry. I'm very, very excited to get started. Let me just make one adjustment to my microphone. Hopefully that will make it a little easier for you, excuse me, for you all to hear me. Well, today we are going to go ahead and get started. On Friday we had our makeup class, so I told you that your homework was not due until this Friday, so we are not going to go over last week's homework. I want to give everyone a chance to write up their lab reports. This week, we are going to talk about something pretty interesting in my opinion, and that is food and our bodies. We eat every day. We eat, some people 3 meals a day, some people 2 meals a day, and some people, maybe you guys, if you're like my kids, like to snack all day long. Well, today we're going to talk about different foods and how they help and hurt our bodies. So what I would like to start by doing is up on the whiteboard, I'm going to make a rectangle. In that rectangle, I would like you to tell me what is your favorite food. Go ahead and let me know what your favorite food is. I'm going to place mine up here. My favorite food is pizza. So go ahead and put your favorite food up here. There is no wrong answer. There is no right answer. We just want to try and use this information in a little bit. So I see a mint chocolate chip ice cream and pizza. I see my pizza. Your favorite food. Again, there's no right or wrong answer in here. Chili and tacos. I'm guessing we're getting a macaroni and cheese up there. Ice cream. All right, so some soup. These look like some great, great foods. Scrambled eggs. Okay, we have another ice cream I'll add up here. Okay, this is a great place, a great starting point. Now, some of these foods up here are not very healthy for us, and I'm sure you know that. Some of these foods are really unhealthy for us, and some are okay. So we're going to take a look at what different parts make up these foods. Now, the different parts I'm talking about are 3 things. And I'm going to put the 3 words right up here for you guys. Those 3 words are carbohydrates, fats, proteins. Today we are going to learn what these 3 are and what group these foods fall into. Now, some of them can fall into more than one category. Just so I know where we're starting, can you guys give me a smiley face if you know the difference between carbohydrates, fats, and proteins? All right. All right, fantastic. We're going to get started by looking at your PowerPoint screen. So I turned my video off, and go ahead and make your PowerPoint larger. And this first slide is labeled Your Body. Your body is a wonderful machine. It works hard on growing bigger and stronger. Especially when you are your age, your body is working hard at growing stronger muscles, stronger bones, and making your body mature. Your body can repair itself. If you get a paper cut this afternoon from your math assignment, within a few days that cut's going to be gone. The cut is gone because your body healed itself. If you are unfortunate enough to be like my son was, playing soccer at recess and break your arm, your body will heal it. Your body changes itself from a child to an adult. Your body runs all the systems needed to keep your body working, meaning your body breathes. Your body pumps blood using your heart. Your body keeps itself healthy. Your body is the more complicated than the most expensive computer, but yet it is free. We just need to treat our bodies nicely. And one of the ways we treat our bodies is by providing them fuel. Just like you have to put gas in your car, you have to put fuel in your body. And we put fuel in our body by eating. Now, you guys listed your favorite foods up here, and someone put mint chocolate chip ice cream. That is fuel, but I'm guessing that's not the fuel that you get to eat every day. Because if you got to eat mint chocolate chip ice cream every day for breakfast, lunch, and dinner, you wouldn't be very healthy. So it certainly is one type of fuel, but not the only fuel that's going in your body. We put proteins, carbohydrates, fats, vitamins, and water in our body for fuel. Can anyone give me an example of a type of food that would be healthy for you? Good for you to eat. All right, we're going to start with Brianna. Go ahead.
Broccoli, spinach, milk, and carrots.
Awesome. Mallory, give me a couple foods.
Salad and fruit.
Very good. Shelby, give me a couple of healthy foods for you.
Strawberries, apples, and oranges.
Great. And Elizabeth had put oranges up in the text chat as well. Zana, I believe you had your hand up too. A couple of healthy foods.
Eggs and fish.
Eggs and spinach. Awesome. I love spinach quiche. And Brooklyn, give me a couple of healthy foods.
Vegetables, fruits,
Fantastic. Those were all great examples of some healthy foods that help to fuel our body. Now, some of those foods that you guys listed were proteins. I believe it was Zana who said eggs, and maybe Brianna who said milk. Those are examples of foods that have a lot of protein in them. So does anyone want to volunteer to read this slide and tell us what a protein is? Shelby, go ahead.
protein It is a very important nutrient because it builds up your muscles or organs and glands. It helps repair and replace them too, so that your body can keep on working.
Thank you very much, Shelby. Proteins help your body to build muscles, organs, and glands. So, not that I expect that any of you look like the little muscle man picture on this slide, but his muscles are so big, he has lots of protein in his body. Examples of proteins are meat, chicken, fish, eggs, nuts, dairy products, legumes. Lots of times, if you are a vegetarian and you do not want to eat meat, you will have to eat lots of types of nuts and lots of legumes to get enough protein so that your body can continue to build muscles and protect itself and heal itself. Mallory, do you have a question?
Is most of the protein come out of an animal, like eggs and dairy products and meat, chicken?
That's a great realization. Most protein products do come out of an animal, like the meat from in a steak, chicken, dairy products like milk. Most do come directly out of an animal. Great job making comparison. So next we have carbohydrates. Now carbohydrates are a little bit different than proteins, but they are something your body still needs. Would anyone like to read about carbohydrates for us? Mallory, go right ahead.
Carbohydrates. Sugar, simple carbohydrates because of your body digestion quickly and easily. Starches complex carbohydrates. It takes your body longer to digest.
Thank you. Great job. So carbohydrates are basically sugars and starches in your body, and they are where you get your energy. Oops. So can anyone think of some examples of something that might be a carbohydrate? I will give you one example and see if that helps. A potato is a carbohydrate. Shelby, can you give me some examples?
Pasta.
Very good. Pasta is a carbohydrate. Brooklyn.
And sugar.
Very good. Sugar, like table sugar that maybe you add to tea or coffee. That is a carbohydrate. Brooklyn. Make sure you hit your talk button, Brooklyn. Do you have one you want to share with us? All right, Brianna, go ahead.
Cupcakes, corn, and pie.
Awesome. Cupcakes and corn are great examples. And Elizabeth had texted in the chat cookies. Those are all great examples of carbohydrates. Fats. Fats are the next category. Anyone want to volunteer about fats for me? Shelby, go ahead.
Fats. Saturated fatty acids from animal foods, dairy foods, and some oils that come from plants. Unsaturated fatty acids from plants, fish, and most plant oils. Unsaturated fatty acids from some plant products such as olive oil and canola oil.
Great job. Thank you very much. Well, there's 3 types of fats. Most of the foods that we've talked about already fall into one of these categories, except for the fruits and the vegetables. But if we talked about some steak, if you were to have a steak for dinner tonight, you would be eating protein, but that steak also has some fatty acids in it. And you need that fat in order to live. Your body has to have some level of fat in it in order to live. Now, if you were to eat salmon for dinner or rainbow trout, that has some unsaturated fatty acids in it. And let's say your mom decided tonight you were having a vegetable stir fry, that she was going to cook the vegetables in olive oil. You then would be having some unsaturated fatty acids in your dinner. The cookies Elizabeth mentioned in the last carbohydrate, they have some fatty acids in it. And the ice cream that people mentioned as their favorite food, or the pizza, those definitely have some fatty acids in the cheese of the pizza and in the dough or the bread of the cookies. So what do fats do? We hear a lot on TV that, oh, fats are bad, you can't eat too much fat. But fats have a very important role in our body. Does anyone want to read this PowerPoint screen? Xana, go ahead.
Fats do. Acts as the body's reserve tank of energy, products our organs like a cushion, helps our body stay warm in cold weather, helps hormones keep blood pressure steady, helps keep skin and hair healthy, gives items of a place to stay, and help them get round in the blood to where the body wants them.
Very good. Thank you very much, Xana. So basically, the fat has a very important role in our body. It acts as our reserve for energy. It protects our organ. It helps keep our skin and hair healthy. It gives the vitamins a place to stay and helps them get around to where they need to be in our bodies. Water. Water has another very important role in our body. So take a look at this PowerPoint slide. Water makes up a large percentage of our body. Go ahead and give me a smiley face if you've ever heard someone tell you, make sure you drink your 8 glasses of water every day. Great. Well, it's because drinking 8 glasses of water every day is really important for our body, especially if you live somewhere where there's extreme temperatures, whether it be somewhere very hot, so your body sweats a lot, or whether it's somewhere very cold, where your body can become dehydrated very easily. Shelby, go ahead.
I live in the desert.
Well, then you certainly need to drink lots of water so you do not become dehydrated. Mallory, go ahead.
I'm also going to stop pushing into it because I drink 8 glasses of water a day.
Fantastic. Well, drinking exactly 8 glasses of water isn't the point, but most people don't drink enough water. Your body has a hard time telling you that you're thirsty until it's kind of too late, until you're past needing that drink of water. So let's look at what water does for our body. Why is water so important for us? We're going to start at the head of this little person and work clockwise. So the first thing up here says it's needed by the brain to manufacture hormones and neurotransmitters. So the water in your brain helps you think better, basically. It helps keep your body in homeostasis, which means it keeps the balance in your body. It helps you keep a good temperature. The second one over by the man's shoulder says regulate body temperature, sweating, and respiration. Having enough water, being hydrated, allows you to keep your body temperature. Does anyone know what the average or the normal human body's temperature is? Mallory, go ahead.
Um, 97 or 98.
Awesome. The normal human body temperature is 98.6. Some people always are a little bit more than that. Some people always are a little bit lower than that. But the normal human body is 98.6. Water also acts as a shock absorber for your brain and your spinal cord. It helps your brain and your spine kind of stay where they're supposed to be. It converts food components needed for survival, meaning it helps a lot in digestion. If you don't drink anything, your body can't absorb the nutrients, the fats, the carbohydrates, the proteins from all the foods that you're eating. Water helps to deliver oxygen all over our body. Water is the major component of most of our body parts. Water lubricates your joints, makes it easier for you to bend your knees, move your elbows. Mallory, you have a question?
If the regular body temperature is 98.6, then how come when you eat cold food, it makes you really cold when your normal temperature is 98.6?
Very good. Can you repeat the last part of that again? Because I didn't, it got a little bit blurry.
It said, if your regular body temperature is 98.6, then how come when you drink cold food or eat cold food, it makes you cold when your regular body temperature is 98.6?
Well, your regular body temperature is 98.6, and having enough water in your body allows you to keep that temperature. You can still eat if your body's not at that temperature, but it just keeps your body in what is called homeostasis, which means your whole body is kind of in balance. Think of it like a seesaw at the park. Your body would be in homeostasis or balance when you're on one end and the person on the other end weighs the same exact amount as you. You can go up and down very easily, and if neither of you move, the balance or the seesaw should be straight across. If your body is out of homeostasis, that usually means something's wrong. Either you're sick, you don't have enough water in your body, you're not eating enough carbohydrates. So it would be like you being on one end and your parents being on the other end. where it's very hard to move up and down. If you're both sitting still, your parent's side would be way at the bottom and your side would be way at the top. It just throws everything in your body kind of out of alignment. Hopefully that answered your question. Water is also very important because it flushes your body's waste. Every time you go to the bathroom, you're getting rid of water in your body and waste in your body. Water allows your body's cells to grow and reproduce and successfully survive. Water helps keep your mucous membranes moist, the membranes inside of your nose, inside of your mouth. Having moist membranes in your nose allows you to stay healthier. Water also allows saliva to form so that it is easier to digest. Today, we are going to focus on starches. And we are going to do a lab activity on starches. We're going to try to determine what foods have a lot of starch in them, what foods have no starch in them, and what foods have a little starch in them. So before we do that, let's look a little bit more at what starch is. Well, starch is something that converts into glucose for energy. And I put a picture of a potato up here. Potatoes are something that typically are very high in starch. Now, you can buy potatoes that are less or lower in starch. If you are going to test potatoes today, we'll cross our fingers and hope that they come out good. There are a lot of factors that can affect the amount of starch in a potato. One of them being how long that potato has been sitting in either your cabinet or the store's shelf. And potatoes generally last a really long time. So if you have potatoes, even if you just bought them yesterday, they could be sitting at the store for a few weeks. So let's look at what happens to a starch and how it is digested. Or, as Elizabeth just wrote, how long they've been stored in the basement, exactly. So, how does starch enter your bloodstream? Well, we're going to start with you are going to eat something that is starchy. So let's say you're eating a piece of bread. The breakdown of the starches begins in your mouth. And as you chew, saliva breaks that complex starch into a simpler sugar called maltose. That happens up in your mouth and in your upper digestive system. Then the maltose goes down into your stomach and into your small intestine. In the small intestine, that maltose breaks down into glucose. The glucose is then absorbed into your bloodstream. The glucose, once it is in your bloodstream, gives energy to your cells. So how much do you need so that you can have enough energy to survive? Well, about 45 to 65% of your calories each day need to come from starches. So it's hard to give you an exact number, but an adult is supposed to eat about 1,800 calories. You guys need to eat more than that because you are still growing. But if an adult is eating 1,800 calories, about 800 to 1,100 of those calories need to come from starches. Main starches in most of our American diets are corn, bread, pasta, rice, quinoa, peas, and squash. So we are going to go ahead and take a look at some starches in some of the foods that you guys would like to test. So Brianna, if you have a question, go right ahead.
What is corn?
Great question. Quinoa is a type of grain that is called a superfood. I believe it is sort of a cross between corn and pasta. I'm not actually going to test quinoa today because I do not have any, but it was just an example of a type starch. So what I would like you to do is when you have your materials for today's lab, which are iodine and a few foods, I would like you to click yes. If you are not doing today's lab with us for whatever reason, because you don't have iodine, you don't want to use the iodine, just go ahead and click yes now so that I am not waiting for you. Shelby, go ahead.
We don't have iodine, but my mom went to the store to go buy some. So I'm doing it.
Okay, well go ahead and click yes, and when she gets home you can use it. That certainly wasn't necessary. So it looks like we're just waiting for a few more. If you don't want to or cannot do the lab with me, that is fine. I am going to do it on camera so that you all see what is going on. A word of caution before we do today's lab is that iodine will stain whatever you get it on. If you get it on your hands are going to be brown for a couple of days. If you get it on your clothes or on your mom's brand new fancy tablecloth, chances are it is not coming out. So please, if you need to put something down where you are working, please do so. Brianna, you had a question?
Yeah. I don't forgot what I was going to say.
That's fine. Not a big deal at all. So basically, how we are going to set up today's lab, and I'm just going to turn my screen here so you all can see it, is we are going to have a plate that has the food items that we are going to test. There we go. So I have a lot of food items that I'm going to test to try to give you guys a good example of what's going on. I have some foods that I think will be very starchy, and I have some foods that I think will not be starchy. So I have tortilla chips, cauliflower, regular club crackers, multigrain club crackers, I have cooked pasta, cucumber, and a piece of chicken. Now, to do this lab, make sure you shake your iodine. Remember, it will stain, so try to be very careful. The first thing I am going to test is my pasta. Now, iodine is brown in color, and I'm going to take it, and I'm going to touch the pasta in a few spots. And I'm going to let it sit for a couple of seconds. Go ahead and pick one of your foods and do the same things. Hold on 1 second if you're asking a question. You will know if your test is positive if it turns purple or black. If your test is negative, it will stay the brown color. So I'm going to put, it'll stay this brown-yellow color. So I'm going to pick my plate up so everyone can see it better. And we can see that for my pasta, it turned purpley blacky. And you should be able to see the brown sort of control right here. So for pasta, mine is a positive reaction. All right, if you had your hand up, go ahead and let me know who had their hand up. Brianna, go ahead.
You know where to find iodine?
Where to find it in the store? You can get iodine in the store. I got mine at CVS. You can get it with the first aid supplies, like the Band-Aids, mine was right next to the Neosporin, like the bacteria stuff. It actually is a supply used to help clean out cuts. That's what you use. So it is blue, and I will hold it up again, Elizabeth. It's kind of, let me move some of my other foods here. It had a positive reaction. It was changed purple, and here's my control that's more yellowy. Okay, so now I'm going to test a second food, and I'm going to choose my cauliflower. And then I would like to see some of your results. So if everyone can choose 2 or 3 of their foods to test, and then if you'd like to share, we will do so. I'm going to test my cauliflower, and I'm going to test my tortilla chip right now. So if you are testing along with me, go ahead and test 2 more of your supplies or your foods. Let's see what happens. So here I go, testing my tortilla chip. And here I go, testing my cauliflower. This is uncooked cauliflower I'm testing. And let me bring my stuff closer to my camera here. So I have my cauliflower right here. My cauliflower did not change. So that means there is no starch in my cauliflower. And if we look at my Tostito chip, it did change darker black. So there is starch in my Tostito chip. And I'm also going to quickly test my 2 different types of club crackers. I have a whole wheat cracker, and I have a regular club cracker. So let's see the difference, if there is any, between the amount of starch. Or if they both have starch. Okay, so here we have, and I can hear you guys raising your hands. Just let me finish, and I promise I will get to you. Here we have my regular club cracker, and it changed purple. And here we have my whole wheat club cracker, and it changed purple as well. Now I have 2 more items to test. I have a piece of cooked chicken, and I have a cucumber. So let's test these. Cooked chicken and cucumber. Now both my cooked chicken and my cucumber ended up staying negative. They did not change purple, So that means there is not starch in cucumber and chicken. So would anyone like to share their results with us? All right, Xana, go ahead.
Everything turned purple.
Would you like me to turn your camera on and you can show us what you tested and what your results were, Xana?
Yes.
All right, it's coming on, and then go ahead and hit the start and share your results with us. Oh, there you are. Your microphone's not on, Xana. Go ahead and turn it on so we can hear you.
Okay, sorry that, but I not have my finger. But here's bread, crackers, potato, and pasta, and they all turned purple. So they all turned purple for me. So I guess that's good.
Starchy.
So they are starchy.
Great job. You are 100% right. If they all turned purple, they are all starches. Great job. Did anyone test any other items that they would like to show on camera? No other takers? Ian had written in the text chat that he had a little problem with the lab, which obviously happens when you're doing a science experiment. He said that he used decolorized iodine and nothing changed. So to me, that says that decolorized iodine must not change colors when it reaches a starch. I did not even realize there was such a thing as decolorized iodine, so I'm sorry that I did not put that in the syllabus, Ian. But do you have a question?
I was going to show my project. I was going to show my project.
All right. Mallory, go ahead.
Yesterday, on Saturday and Sunday, I done this experiment, and I found out I mixed borax and vinegar, and it was really sticky and bubbly. Then I put baking soda in the vinegar, and it went everywhere. And so I let it die down, and I stirred it up a little, and I found out when baking soda is moving and active, it gets more active. Like it starts to fizz and bubble and go everywhere. And I found out that the more active it is, the more it moves.
Well, that was a great little observation that you made. Great job, and thank you for sharing that with all of us. Elizabeth, go ahead.
Does cooking change the starch content?
That is a great question. And it usually has some effect on the amount of starch. And it's not necessarily that it changes it, but it changes how it is. For example, if you were to take pasta and you were to boil pasta in water for 10 minutes, what's happening is the pasta is releasing some of those starches into the water that you're boiling the pasta in. So, for example, if we took regular water just out of my faucet and tested it, it shouldn't have any starch in it. However, if we took some water from my faucet, boiled pasta in it for 10 minutes, then the water from that pasta, if we tested it, it should have some starch in it because the pasta is releasing some of the starch. So if you were to boil pasta, boil potatoes, some of the starch goes into the water, causing there to be less starch in the pasta and the potatoes. However, in this lab, we weren't necessarily testing the number of, the amount of starch. We were just testing, yes, there is starch, or no, there is not starch. Between a raw and a baked potato, Elizabeth, they should have the same amount of starch. But a potato that you grow in your garden may have a different amount of starch in it than the potato I buy from the grocery store. Mallory, you have a question?
Yes. This is going to involve the week that we had the acids and bases. And so are some of these starch foods and the foods that we're talking about today, do they have acids and bases in them?
Well, everything is an acid or a base or a neutral. So I don't know off the top of my head what the pH of pasta is, but it has a pH of something. So I can probably, if you give me a second, look it up and let you know if it is an acid or a, but everything around you is either an acid, a base, or neutral. So I just looked it up, and it says that the pH of pasta is usually between 5.97 and 6.4. So everything has a pH. So let's take a second, and let's look back at our initial page on the whiteboard that we were working on. Xana, you have a question?
My dad just mixed sugar and starch together, and
Sugar and iodine.
Sugar and iodine, and they found out they have a lot of iodine in it. Starch in it.
It does. That's fantastic because sugar is a carbohydrate, so the iodine will react with it because it's starchy. Great job doing a little bit extra on our experiment, Xana and your dad. So let's take a look back at our first whiteboard screen that we looked at. And I'm going to ask you guys to do something. I have, next to our favorite foods, I had written carbohydrates, fats, and proteins. Now I want you to think either about your favorite food that you put up here, or you can pick another food if you want. And I want you to write it and classify it as either a carbohydrate and put it in the carbohydrates rectangle, a fat and put it in the fat rectangle, or a protein and put it in the protein rectangle. Some of these foods can go in more than one of these spots. So, for example, I had pizza up here. So if I take pizza, well, pizza does have some dairy in it, so it can be a protein. And pizza crust is made with carbohydrates, so we're going to put pizza up here. And pizza does have some fats in it, so we're going to put it over here as well. So pizza actually has carbohydrates, fats, and proteins. So go ahead and put your food into 1, 2, or all 3 of these. Okay, we have some great descriptions up here. We have whoever had mac and cheese, put that in carbohydrates and fats, but not in protein. Perfect. We have ice cream in all 3. Great job. We have soup up in the carbohydrates. We have in the proteins, chocolate in the fats, and milk in the proteins. Great job working your way through that and kind of figuring it out. Last week on Friday, we had talked a little bit about your final project. So I want to talk about that again with you guys. Next week is our last class. Now, for our last class, you guys are going to be in charge. You each are going to choose a topic in science that you are interested in. It can be a topic related to kitchen chemistry, or it can be a topic that is just science in general. If you look up on your PowerPoint screen right now, the top right square, I have your assignment up here. You are going to research your topic using the internet, using books, or you can interview somebody about it, you know, your mom, your dad, a friend who is knowledgeable about your topic. Then you are going to complete either, I told you last week, a presentation. However, someone asked me a great question. They said, well, what if we want to do a mini lab? And I said, that's a great idea. So you can either do a presentation, like make a PowerPoint to tell me about your topic. So let's say you choose acids and bases in my kitchen, and you just want to explain to me some acids and some bases in your kitchen. So you make a PowerPoint, or you make some pictures you want me to upload for you. Fantastic. But let's say you decide, I want to do an experiment with Ian, thank you. Let's say I want to do an experiment where you are testing the effect of vinegar and baking soda together. So you are going to go ahead and do a little lab and show us in class. That's fine. I can turn your camera on. You can show us your lab in class and kind of walk us through it, just like I do when we do a lab together. I'm going to answer all the questions in a minute, guys. So you can do one or the other. your whole presentation, whether it's an activity, a lab, or an actual PowerPoint, should be between 3 and 5 minutes. I don't want you to get up here for 25 minutes. We don't have time for that. Okay, so make sure it's short. Make sure it's interesting. If you want pictures added or a PowerPoint added, you just need to email it to me or upload it to Moodle. Now, Ian just pointed out that I put the wrong due dates up here. I put your project is due by February 30th. Well, there is no February 30th. I obviously was looking at the wrong month when I was doing my paper here. Your presentations are due next Monday, which is March 2nd. However, your topics are due to me by tomorrow. So in Moodle, there is a homework assignment that says Final Project Topic, and that is where you are just going to type your topic. I need you to do that by tomorrow. I want to make sure that all of you do not choose the same topic. You will hear back from me as to whether or not your topic is okay. It's going to be first come, first serve. So I'm going to answer all of your questions in a second. So if, for example, Elizabeth, Brooklyn, and Ian all say they want to do vinegar and baking soda, I'm probably only going to let the first 2 people whose Moodle I get do it. So you will hear back from me, but if you have a topic in your mind, make sure right after class you go and submit it to me. And your presentations are due next class, March 2nd, and I will change that date. So Brianna, you had a question. What was your question?
See why baking soda and vinegar exploded, and can I do a video one?
You certainly can do a video if you would like, and then just send me the link to the video. That is fine. The first part of your question I couldn't understand, so make sure you move your microphone a little bit away from your face.
I wanted to see if I could try a baking soda volcano one. I wanted to see what...
You sure can. You just need to submit it to me in Moodle. So go ahead and submit it, and you sure can. Does anybody else have a question? No? Okay, well, next week is our last class. You're going to do your presentations, and I'm going to do a couple of fun little science topics for you guys. Xana, you have a question?
So we are going to see if gas is produced by mixing baking soda with vinegar to blow up a balloon.
Sounds good. If you could just go ahead and submit them to Moodle, that would be great. That way I can keep track of them all, and I can make sure that everyone sends me a topic. So Brianna and Xana like fantastic ideas, both of them. You only need one project, Ian, and just submit them to Moodle. I will send you an email back saying, perfect, I got your submission, great idea, and you can go ahead and get started. Alrighty? I hope you guys have a fantastic week and enjoy working on this project. It should be something you spend, an hour on. Don't spend a ton of time on this unless you're really enjoying doing it. I hope you guys have a great week, and I will see you next Monday for our last kitchen chemistry class. Brooklyn, you have a question?
I just forgot what you said for us to do in the morning.
In the morning? I don't know that I said you had to do something in the morning. by tomorrow, I want you to send me your topic that you're going to do your presentation on. Maybe that's what you're thinking of?